morning, everyone. My name is Amin Manena. I am the Coordinator of Technical Products and Research at Good Roads. I will be your moderator for today's webinar. Just a quick housekeeping before we start. We encourage all of you to ask the questions as you think of them and type them in the Q&A function or the chat function at the bottom in your tools menu, your tools bar for Zoom. The questions will be answered at the end of the webinar. So you type them in as you think of them, but we'll collect them all. We'll answer them at the end of the webinar. The webinar is recorded and will be made available on our YouTube channel a couple of days after the webinar. So today's webinar is Optimize Your Budget, Spiral Rib Pipe for Storm Sewer. It's co-presented by Ray Wilcock, Executive Director of CSPI, and Doug Leach from Armtech. Ray is the Executive Director of the Corrugated Steel Pipe Institute. He holds a science diploma from Champlain College and a Bachelor of Commerce from Concordia University. In 1985, he acquired CPA, CMA, and in 2004 was conferred with the title FCPA and FCMA. On graduation, he started with the Dominion Bridge, a company who built many of the major bridges crossing across Canada. Over the past 3 decades, he has held a number of senior executive positions at several corporations in the infrastructure industry. Doug is Armtech's regional engineer in Ontario. He has a Bachelor of Science degree in engineering from the University of Guelph and is a member of the Association of Ontario Engineers of Ontario. Prior to joining Armtech, he worked as a hydraulics engineer with S&C Lavalin and water management supervisor for Upper Thames River Conservation Authority. Since joining Armtech, Doug has held several positions, including Manager of International Sales, where he worked on projects in over 40 countries. So thank you both for taking the time today to deliver this exciting presentation. With that, I'll hand it over to you, Ray. You can go ahead.
Thank you, Amin, and thank you for those who are attending today. The outline that we're going to cover today is I'm going to just talk briefly about the Corrugated Steel Pipe Institute, the CSPI. I'll touch base on standards and guidelines, a little bit about the spiral rib profile and coatings, durability of the different materials that we have. Doug from Armtech is going to cover the design overview of spiral rib pipe, go through a few of case studies that he has been involved in over the years. And I'm going to close off with the environmental carbon footprint of spiral rib pipe. The Corrugated Steel Pipe Institute is an association whereby we represent the manufacturers who manufacture corrugated steel pipe, spiral rib pipe, structural plate corrugated steel. Armtech and Atlantic Industries are major players that have plants right across Canada. Hubcap and Frontier produce products on a regional basis. We also have as a member the largest steel producer in the entire world, ArcelorMittal out of Dofasco, Hamilton. They have over 55 to 60 plants worldwide. Advanced Coil Industries do coatings for the material. Ironside make machines that make corrugated steel pipe. AK Steel is a large steel producer of aluminum and aluminized type 2 steel. Leland Industries do nuts and bolts, and Warner Custom Coatings also do coatings for the structural plate, polymer coated. We also have members outside of North America, or outside of Canada. Belfilm is in the United States, and they produce film for polymer laminated, and we'll talk about that today. CMP Manufacturing and Rondell are out of Australia. 2xO is in Paris, France. Viacon is out of Poland. Birkenhoek is out of the Netherlands, and Marmac Construction Products is out of South Carolina. They do actually couplings and so forth. They're a new member of CSPI. And many people have asked me why, we have international members for a small Canadian association. And the reason why is because these particular members, we have over the years done a lot of things on research, development, guidelines, standards, and so forth. So working with us and them, you may have only one or two players in, let's say, some of the countries over in Europe. So they rely on us for a lot of the technical information that we provide, and vice versa. We also learn from them and their markets and as to what they do overseas. So moving on to some of the standards and guidelines that we have CSAG 401. I am the chair of that particular committee, and that covers basically all material standards for corrugated steel pipe and structural plate, spiral rib. And that standard will be updated in 2022. So the committee will be pulled together within the next couple of months, and we'll go through the process, make our updates, and have it approved going forward. I'm also members of ASTM, and these are some of the different standards that are used up here in Canada, A742, 760, and 762. We have AASHTO, also in the United States for the highways and roads. And in Ontario, OPSS 1801, OPSD 805. We also have, for instance, within Ontario alone, the provincial standard, the Ontario Gravity Pipe Design Guidelines. This is a guideline that emanated back around 2004, 2005. I was part of that committee way back when, and it covered and looked at all of the different materials from that you could possibly want to pick for culverts and storm sewers. And then we also have municipality standards that we get involved in and so forth, not to say provincial standards and so forth. So a little bit about the spiral rib profile and the coatings area. This is a culvert. So a little different from spiral rib, just to show you, from upstream to downstream, underneath maybe a road or a highway and so forth. And there are millions of these across the country. And they can be, as you can see, silver on the left and say black on the right. And sometimes they can come one or maybe, the most I've ever seen in a crossing is probably close to 13. But this is what we're going to talk about today. This is a storm sewer. It's a spiral rib. So it is smooth wall inside, ribbed on the outside. Sometimes they come with risers, or sometimes they can be connected to a, say, a concrete manhole and so forth. The Manning's N for the smooth wall inside is 0.012, which is equal to, say, a smooth wall concrete or a smooth wall high-density polyethylene pipe. The profile for spiral rib is 190 millimeters, okay, from rib to rib, and then 19 from rib to valley, down into the valley. And then you can see some of the other profiles we have. Those are corrugated steel pipe, so they have ribbed on the inside and outside. So spiral rib's a little different. A little bit about durability. I wanted to show you, this is a pipe that is about 85 years old. It is a riveted pipe. It's just outside of Winnipeg, Manitoba. You see all that white stuff on that pipe? That is calcium carbonate. So it forms on the pipe from hard water conditions. It protects the zinc. This is a galvanized pipe, so it protects the zinc, which protects the steel. So that pipe is 85 years old. Provided that water doesn't change and it continues to be hard and that calcium continues to stay on there, that pipe will last pretty well forever. However, if you take that same pipe and you put it into another jurisdiction in Canada, it will not last as long because, you know, the water chemistries, the soil chemistries can be quite different. Now, this is a pipe I wanted to show you here in just outside of Grand Prairie. So it's on I think it's Highway 43. It's between Edmonton and Grand Prairie. And you see all that bottom picture. This picture was taken back in July 2003. You see all that white stuff on the bottom of that pipe on the left-hand side. That is salt. So heavy chlorides. That salt stays in those pipes 365 days of the year. So With the salt, which can be very corrosive and so forth, you need better protection. So the protection on those pipes are polymer laminated steel. So you have galvanized steel with a polymer laminated 12 mil coating on either side of the pipe to protect it from that salt and that corrosiveness and so forth. I've been to that site many years. It's a great site to go and look at and make sure that the coating thickness is good. And as I said, that salt that we took, that you can see in July 2003, is the same as what you would see today if you were to visit that site. The topography of Canada is quite different. If you look at, say, the West, Alberta, parts of Saskatchewan, parts of Manitoba, and even parts of Ontario, you will see the green. That is basically, you have very heavy limestone, so you have a very calcium carbonate buildup, and you can get away with, say, using galvanized steel and so forth. But as you get into more acidic environments, particularly in areas like Quebec and parts of Ontario and then parts of the Atlantic provinces, you're going to want a different coating. You're going to want to use aluminized galvalume, or you're going to want to use polymer laminated. So here are the 4 coatings, and this is how you would get a 75 to 100 year design service life from these 4 materials, whether it be galvanized, aluminized, galvalume, or polymer, based upon these types of chemistries that you're dealing with. So for instance, you have the coating across the top, you have 43 microns of zinc for galvanized, and then going across the page, you will see the different coatings for the different materials. The gauge will go down because as you get a stronger coating like a polymer, you don't need a thickness of steel that you would versus say galvanized. So for instance, for galvanized, to get the 75 to 100 year design service life, we need to use a 3.5 millimeter thickness. For aluminized and galvalume, we can use 2, and then for polymer, we can use 1.6. And then you can see also the pHs. Galvanized performs extremely well in neutral, which is 7 to 9. Aluminized, you can see where it performs well. And then polymer, which is basically 3 to 12, which basically covers pretty well everything that's out there. And then resistivity, same thing. 2,000, 8,000 ohm centimeter for galvanized, and then going across the board, you'll see that the other coatings perform much better in lower resistivities. And chlorides are in parts per million. These are basically salts, but they can be a number of things that run off. And you can see polymer will even perform in greater than always almost up to 900 parts per million, which is basically seawater. I've tested water, and like brackish water, which is a combination of seawater and fresh water, you're talking about 700 to 800 parts per million. So you're getting up into the seawater areas. Okay. And there's a few pictures of, you have galvanized here, you have aluminized here in the middle, and you have polymer laminated spiral rib pipe over here. And then one more chart I wanted to show you. This is what I use a lot when I am testing water and so forth. So I'm able to go to a chart and determine what type of material I would use for that particular environment that we're dealing in. And again, it covers pHs, resistivity, hardness of water, and also chlorides. So now I'm going to stop sharing, and I'm going to turn the presentation over to Doug Leach.
Hello, everyone. My name's Doug Leach. I work for Armtech, and welcome to my portion of the presentation. That's this thing. There we go. Okay. We're going to talk about some design fundamentals, both structural design and durability design. And I'm going to touch on both rigid pipes and flexible pipes because it's good to understand the difference between the two of them, and also at the same time the codes and the information that's needed in order to do these designs. So first of all, flexible pipes include high density polyethylene, PVC gravity pipes, and of course our corrugated steel pipe. And the interesting thing about them is they're all thin walled, They're flexible pipe in that they'll move around a little wee bit, and certainly they gain the strength from the soil interaction. The backfill is important. It's granular, well-graded material with known properties, and known properties certainly include the chemical characteristics of them, as well as Ray related to you earlier. A little bit about how the actual response is. If you look at this, the important part of designing any pipe is typically the height of cover, or the distance between the top of the pipe and the load carrying surface, in this case, the roadway that you see here. That particular minimum cover is important because it keeps a bending moment small enough that it doesn't disturb or hurt the pipe at all. And secondly, it prevents what's called soil wedge upheaval. And by soil wedge upheaval, you can see this area right here and this area at the 1 o'clock position. When the load approaches, there's a tendency to push that cover back up. So pipe has to be buried deep enough to withstand that. Typically, the pipe is, and this isn't always the case, but the important part is the height of cover, and that may typically be diameter divided by 6. That's a very common way of considering it. If we look at this a little bit closer, you can see this is the response of a flexible pipe. The load is applied vertically to the road surface, and then that's distributed through the height of cover and onto the pipe. As a flexible pipe, this has a tendency to push the structure down. And as it does, it mobilizes the side support here, keeping it in place. And you end up keeping the pipe circular, and you end up with what we consider and call ring compression, where it holds the whole pipe circular, and the soil and the pipe itself act together. That's kind of distributed, or excuse me, that's kind of demonstrated in this particular slide, where you can see on the left a flexible pipe. There's a uniform pressure around the outside, and the pipe itself acts in conjunction with the soil in order to keep it in place. The soil plays a major part in carrying the load from above. Now, if you consider rigid pipe in the other sense, it's a stiffer pipe. And as the load is applied to the top, there's less of support on the side and more of it distributed to the bearing strength down below. And so you kind of think that the pipe has got to be a little bit stiffer than the backfill in order for this to occur. So those are kind of the two types of design in pipe design. Flexible pipe, all kinds of pipes have design methodologies for them. HDPE used the Corrugated Pipe Association manuals. There's a PVC manual for assistance. Our own corrugated steel pipes often use ASTM 796. And some of the other manuals we have, there's AISI design for corrugated pipe. It's kind of the granddaddy of designs, if you want to call it that. And it's found in the Handbook of Steel Drainage and Highway Construction Products. That's a publication of the CSPI Rage Group, and certainly available from him if you're looking for that. When pipes get larger than 3 meters in diameter, you can also use a CHBDC, the Canadian Highway Bridge Design Code. On the rigid side, the design requirements are all laid out in CSAA 257.2, the Ontario Concrete Pipe Association manual, and kind of the granddaddy of concrete pipe design is the American Concrete Pipe Association manual. So the point I'm making here is there's a lot of information on designing pipes. There's a lot of different methodologies of using so. But at the end of the day, the most critical in it is the height of cover. All of these pipes can basically be brought into a very small and important type collection of documents that are produced by the Ontario Provincial Standards Association, the OPSD, and those are height of cover tables, and they're also found in the MTO gravity pipe design guidelines. So it's important that you look at all the documents before, but when it boils right down to it, these documents, these 4 pages in front of you, are very much what's involved in designing pipes, be they sewer pipes or culvert pipes. And in this, you can see there in the top left, here we have the height of fill table for spiral rib. Here's your concrete table here. It's a little more complex because it's a rigid pipe design. So there's a few more details and notes to keep track of. And on the bottom, we have the HDPE and the PVC heighted cover tables. What this shows is I've taken some of the documents, and down the one-hand side, we have the diameter. Across the top is the type of pipe, and the maximum minimum covers are shown here. So for instance, if we look at a 600 pipe, you read this document, okay, HDPE requires a minimum cover of 0.3 meters, 300 millimeters, and it's good to a maximum of 7.3 meters. Now, taking one step further, what this shows is I've assigned a color to each particular type of pipe. And when it's colored, it means that, oh, this is the maximum of all the pipes or the minimum of all the pipes. So for instance, in 600 millimeters, the minimum cover is 0.3 for spiral rib and 0.3 for dual wall. So they both get to show up in color because they're the minimums of the minimums, if I can put it that way. What it basically illustrates, you see a lot of red there, and what that's saying is the spiral rib is extremely good for low cover situations and extremely good for high cover situations. It's a very versatile pipe, and it covers the whole realm of installations that you may require. In flexible structural pipe design, really the heights of cover table is always where you want to start. They'll probably give you a significant portion of what it is you need to know. But remember, always refer to the industry design manuals. There may be things in there that you should consider as well. Use those specific specifications that are listed. And I would encourage you to refer to the MTO Gravity Pipe Manual. This is a document that was prepared by representatives of all pipes in conjunction with municipal and government officials. So it kind of covers the whole gamut of everything. So that would cover your structural design considerations, but in order to get a good pipe, you also have to look at durability design. And Ray touched on this a fair little bit before, and he'll probably finish with a little bit more yet. But what do we mean when we talk about durability design? Well, it's the use of projects, site-specific data, and installation practices to determine an estimated service life, okay, an ESL. But that's not the end quite yet. You're not finished design, because an ESL is then done and put into life cycle cost analysis. Somebody may call it at LCCA. That's a terminology for it. And once you have your life cycle cost analysis, it's only then when you have a proper project pipe selection. So what the manual does is help you a whole bunch to follow your way through this. Estimated service life is a function of soil and water chemistry, material coatings, installation, backfill composition, and flow conditions. Now, soil and water chemistry sometimes might be a little bit difficult to get, but Ray, you can always get a testing kit from the Corrugated Steel Pipe Institute, and there are documents and pieces that have this information in place. So I would encourage you, if you haven't got that, contact your local ARMTech representative or CSPI representative, and they'll be able to help you get that information. But once you sort of have it, this is the document that I was speaking about, MTO Gravity Pipe, and you can see it talks about soil and water resistivity, acid, chloride type of things. It speaks to mechanical resistance. And once you have that, it provides estimated service lives for all the pipes that we're talking about here. that then can be entered into your life cycle cost analysis. So you can follow along with the procedure right there. Just to give you an idea of the kind of information that's found in that particular document, this is a chart which talks about the service life for a 75-year. If you're looking for a corrugated steel pipe to last for 75 years, and this is the document, and I believe these are produced for things like 25-year or 50-year as well. With the information that you may have, for instance, pH and resistivity, if you take, for instance, the pH of 6 and head up here and your resistivity is 6,000, it plops you in this area right here. So what that says is for 75-year design life, galvanized is not the pipe to use. Okay, this is the galvanized section here. It's outside of that range, but this is your aluminized range here in green. So that is a pipe that in that position would be useful. The other one is polymer laminated. It's shown here in black. So it is also going to give you what you want there. So essentially these charts will do a lot of the work that you need in order to get that estimated service life. So we talk about design for structural and durability. Do that, it ensures your project is value engineered. Okay, go through a few case studies here and then we'll go, and then I'll pass it back to Ray. This is a job that's I'll call it a 20-year job. It started back in early 2000s. The city of Sarnia had an area under 1,000 acres of residential subdivisions and 4 schools that they want to expand and service. The job was originally bid in, I believe, 2000 or the late 90s in any case, and it was bid in with both spiral rib, steel pipe, and concrete pipe. And the spiral rib came in at $500,000 less in servicing costs. And the project went ahead with 2.6 kilometers of 2100 through 2600 aluminized spiral rib trunk sewer. This is the job itself. Okay, I don't know if anyone is aware, but this is the Highway 402 overpass that runs from London into Sarnia. This is the job site that's being serviced, and these are the pipes lined up on the edge of the allowance for the sewer. The pipes were offloaded and placed along the right of way, ready to be put in. And the pipes were 8 meters in length. All of them were numbered, so you just plop the number in and drop it into the ground. All the manholes were prefabricated, so they were just set in as well. And you can see here, it went very, very fast. At this point, there were actually 4 excavators working and digging and compacting, and at times they installed approximately 500 feet of trunk sewer in one day. The couplings gasketed with bolted corrugated couplers. You can see here they're backfilling, tamping, compaction. They left the space to add a service tee in. And once they were finished, this is what the backfill envelope looked like. Fast forward in 2018, a developer wanted to add a 200 home subdivision connected to the 2600 trunk with a 1350 millimeter diameter storm sewer. There is no tender called for that in concrete pipe. When they got the bids, the project was over budget and canceled. And the low bidder went back and suggested to the owner, why don't you use spiral rib? And when the project was re-tendered in 2019, spiral rib was selected, had a savings of approximately 35%. And the project was completed later that year in 2019 under the owner's estimate. I'll make a quick comment about this. This is the 1350 here, and this is the service connection into the 2600. And when the service connection was added, we cut a hole into the 2600. And I took that piece of pipe and I sent it to Ray and I said, can you measure this and see how we're doing? And he did some magic with some of his testing and basically found that the coating on that after 20 years, it was 0.5 microns of the coating were gone, or represent about 2% of the corrosion protection. So basically, we still have 90% or over 90% corrosion protection left in that main sewer line after 20 years. A few other projects here. The one on the left is in St. Clair Beach. Similar to the Sarnia job, it was a trunk sewer to service a new area that was being developed. On the right in Leamington, that's that was an open ditch at the time, and there was additional servicing further upstream. So they filled the ditch in with a pair of 2600 spiral ribs, smooth wall pipes. This was an interesting job in the Windsor area, another situation for an expansion further upstream. Very tight room here. You can see the roadway here, the trees and the houses are in between. And they didn't want to get into the road. And as you can see, there was not very much room here at all. Now, the spiral rib pipe, the wall is very, very thin, but in a situation with a concrete pipe, the walls may be as much as 18 inches wide, because they may anywhere be 8 inches width on each side. So this was a very narrow place to fit in. So they're excellent pipes for where there's little confined space and low cover. Project that was done just a couple of years ago in Wainwright, Alberta. That's about 200 kilometers southeast of Edmonton. And again, low cover situation. So the consultant selected the pipe arch shape, and the actual subdivision was up in this area and was being drained down here to Highway 14 across the road, and was going to be dumped out at that point. So here you can see this, the manholes are sitting there. They've been cut out to accept the pipe arch, and the pipe came across here, made abrupt 90 degrees and came out. And there was so little cover that this particular chamber was built, and then they outletted it with 3 smaller diameter pipes. Finally, this was a subdivision, industrial subdivision, again near Winnipeg. Very shallow cover. If you look here, there's not very much room at all over top of this particular pipe. 8-meter lengths, gasketed couplings, and you can see here there's not very much cover, but how simple it is to backfill. He's doing the haunch area, and the pipe would then be backfilled as later. At that point, I'm going to go back and share my screen with Ray.
Thank you, Doug. Okay, so what I am going to finish off with is give you some results of the environmental impact of corrugated steel pipe, spiral rib pipe, and the like. We undertook this study about 4 years ago, and at the time we wanted to know where we stood with regards to our carbon footprint, what our emissions are like, and eutrophication and smog and everything that goes into making of these particular products. If you were to go to our website and look up what is called our environmental product declaration, which is about 12 pages long, you would see this particular page there, which is the results of looking at 1 metric ton of corrugated steel conduit. And basically it's done by a third party. So the data is gathered and they look at it from cradle to grave, more or less. So they look at, where it comes from, how it's produced, then it's transported to a manufacturer, a pipe is made, a pipe is installed, and then it has a life cycle, and then it's either recycled or sent to a landfill site and so forth. So that's the way they look at the environmental product declaration, to give you an idea of, how you are with regards to your carbon footprint. So if you look at this particular chart, it's not easy to understand. And I'm hoping that future environmental product declarations will be much easier for readers to read. Probably you can all do the math here, but it's not easy to do. When you get, like, for instance, for ozone depletion, 1.79 times 10 to the minus 13. Not easy to figure out just off the top of your head. Well, I'm going to just show you quickly, much easier to look at. So it looks at the impact category here with global warming potential, ozone, acidification, which is acid rain, eutrophication, which is that green stuff that's sitting on water and all those, that pollution, which is not very nice. It looks at the ozone layer and then also depletion of fossil fuels and so forth. Okay. So if you were to look at the greenhouse gases of 1 meter length of 450 millimeter diameter pipe, we would produce, corrugated steel pipe would produce 40 kilos of carbon. If you were to take the same 1 meter of concrete pipe, it would produce 80 kilos of carbon for that particular diameter. For corrugated or spiral rib, it would be 158 kilometers driving that automobile or using 1.6 propane tanks on your barbecue. So in this particular example, and the way it's done is a third party will look at it and compare environmental product declarations. So if an EPD is available to the public, you can compare product to product, material to material for the end use and determine who has a smaller carbon footprint at this point in time. Now, we're all trying to get to zero in the future in line with the Paris Accord, but we wanted to look at where we stood right now. Were we good? Were we bad? And what we needed to do to improve and get better. So right now, based upon published results, we have 1/2 the carbon footprint of concrete for that particular diameter. Now, if you extrapolate that out to the larger diameters, the green is spiral rib, the black is high density polyethylene, and the gray is concrete. You will see that as the diameters get bigger, 900, 1200, 1500, 1800, 2100, 2400, you will see that spiral rib has a much bigger advantage to HDPE, advantage to concrete, and the advantage gets very large when you get into some of the larger sizes. Why? Because concrete is very, very heavy compared to, say, steel. We only change gauge with polymer laminated when we get to about 1800 millimeter diameter. So we can use 1.6 millimeter thickness all the way up to that particular diameter. And when we get to that diameter, we shoot over to 2.0 millimeter, but still very thin, basically your earlobe type of thing, thickness and so forth. Again, if you were to go, it's easy for me to sit here and more or less, spew this out and say that we have the smallest carbon footprint. But if you're interested in those documents behind what I say that are produced by third-party companies out there, and these third parties consist of scientists and environmentalists and climatologists and engineers and so forth, you pay a lot of money to do this type of work, but they will determine what your carbon footprint is, and then every 5 years after that, a new environmental product declaration will be provided. So in 2023, we will do a new one and we will determine, are we improving from 2018? And the answer will be, I can tell you at this stage of the game, absolutely, based upon what our members are doing. But the fact is, it will show you the numbers for the last 5 years as to how we're doing. We have an environmental calculator on our website. And it has basically 2 inputs. All you do is you input the diameter in millimeters and then the length, what you're talking about as far as a project goes, how many length you're using. For this one, I just did 306 meter lengths, and it will print out the global warming in tons, which is your carbon that you emit. So CSP versus reinforced concrete, and it will show you the difference. And it basically give you an equivalent of, kilometers driven. It will also show you the fresh water that is used to produce these particular materials. And it's equivalent to the number of plastic bottles that end up in a landfill site. And then it will also show you the total primary energy that is used, electric, basically the equivalent of smartphones charged. So we have that on our website. And if you're interested, please send me a note and I'll send you the link, but it's in our resource section of calculators for the environment. Just to tell you a little bit about the legislation that exists right now, California is the leader in North America. They have what is called the Buy Clean California Act. Therefore, if manufacturers want to provide products to the state of California, they're going to have to meet a threshold of a carbon footprint. And then each year, the idea is to lower that carbon footprint so that, by the year 2050, it is neutral, zero. In Canada, we have what is called the Canadian Federal Government Low Carbon Assets through life cycle assessment. At this stage of the game, we do not have legislation which says that, or in their procurement policies with municipalities and so forth. I would assume one day we will have that, because it's fine for a politician to stand up and say that they're committed to carbon reduction, but unless legislation is put in place to make this happen, carbon taxes are not going to do it. So, I would assume that somehow in procurement in the future, products are going to have to meet a threshold and then be lowered as we move forward. And in my, what I have seen in my research is the city of Calgary is a leading city out there, and they've moved to what is called Envision, which is a type of system where they're capturing their carbon footprint of everything that they do within that city. Procurement, and also, what carbon footprint they have in the city for the vehicles that they use, transportation, et cetera. So I want to finalize here by giving you some advantages of spiral rib pipe. It has a hydraulics Manning's N of 0.012. There have been people out there who said that, CSP has a less hydraulics Manning's end than, say, a smooth wall pipe. That is true for a corrugated steel pipe, but for a spiral rib pipe, it is equal to a smooth wall concrete or smooth wall high density polyethylene or PVC. It has we have the smallest carbon footprint of all materials that exist out there. Now, 5 years from now, maybe that's not the case, but right now that is the case based upon produced environmental or published public environmental product declarations that are out there. Economy, savings to the taxpayer, as Doug pointed out in some of those case studies, huge tax savings to the public, to the taxpayer, and also to the municipalities. We have longer lengths, less joints, faster installation. You can make this thing as long as you want. Manufacturers keep 6 meters or 8 meters in stock, but you can even make it longer if that's what is required. So a lot less joining systems. So lighter weights. We're a leader in minimum and maximum cover, as Doug pointed out. Very misconstrued. You wouldn't think you could bury this 40 meters down into the ground. You can. Installation savings, much easier to put together. And 75 to 100-year service life, if that is what is required. And the transportation savings can be enormous. Sometimes you can ship a full job on one site, whether it's nesting pipe or what have you, versus say others who cannot do that. I just want to show you about a consultant who called me. They had a recent design that was 900-meter length of a 1,500-millimeter diameter storm sewer. They asked me to compare a couple of materials and to give them the carbon footprint of the differences. Just to show you here, this is a difference between spiral rib pipe and reinforced concrete pipe. You can see the total number of pieces. Reinforced concrete pipe is 2.4 meters in length. That's the way it comes. Where spiral rib pipe can be 8 meters in length or even greater than that. But here's the big kicker, is the weight. 80,000 kilos for spiral rib, reinforced concrete pipe, 1.8 million. So it's 4.3% of the weight. So you can see why the carbon footprint is so much lower. Total number of trucks to get it there, excavation volume, thinner versus the thickness that Doug pointed out on the walls, backfill material, installation time, and the carbon footprint. 121 metric tons versus 405 metric tons, or 71% less carbon emissions. Another thing is the cost, spiral rib to RCP. As the diameter increases, the economics really flow through. As Doug pointed out on some of those storm sewers out in Sarnia, a savings to that municipality of $500,000. What can a municipality do with an extra $500,000, by going the route that they did? And maybe they probably wouldn't do this, but maybe they'd lower the tax base once in a while for us taxpayers. Another thing, just to, there's been information out there about, all this stuff is brought in from the US or whatever. Spiral rib pipe is 100% Canadian made by manufacturers right across Canada. The raw materials that make it up are 80% produced in Canada and about 20% out of the United States. And with that, I am done. I'm in. So we're open for any questions that people may have.
You're right. Thank you very much, Ray and Doug, for this really informative presentation. I certainly enjoyed it. I have one question personally before we go ahead and present the questions from the audience. You mentioned that there's significant transportation savings from using spiral rib and corrugated steel pipe. Was that reflected in the carbon footprint report?
Yes, transportation is taken into consideration in the environmental product declaration. So basically, they look at how to transport one material to, and they use an average of, let's say they use an average of 100 kilometers, and they draw rings around plants or what have you, and they determine how many truckloads it would take to transport one material to the other. So because weight is a huge factor, and so yeah, that is taken into consideration, transportation. So there's the getting raw materials, whether it's out of the ground or using recycled material. It is producing it within a plant, transportation to a manufacturer, them doing their process of corrugating and so forth, transporting it to a site, installing it, and then obviously life cycle after that, whatever happens to it. And I can tell you, with steel is 100% recyclable, and it maintains its same properties as if it was from pure iron ore. Therefore, and all spiral rib pipe and corrugated steel pipe is made from recyclable material. So it could be your fridge, your car, whatever, and it's made using the electric arc furnace, EAF, which has no coal. It's made electric in our in plants in Hamilton, ArcelorMittal.
Okay. So the first question from the audience is someone's asking regarding the Ministry of Transportation Flexible Pipe Design Manual. Is that for Ontario? Assuming yes. And can you provide a link to download the PDF document?
I can do that. I have a link. I even have a copy of it if they want me to send them the PDF, but either or, yeah. It's downloaded from the Ontario MTO website, but sometimes it's, you have to go like this sometimes to get through and find it. So yeah, if that particular individual wanted to send me an email at rjwilcock@cspi.ca. So that's RJ Wilcock, WILCOCK @cspi.ca. I can send them the link, or I can send them the document itself, the latest document. One of the two.
The next question is, when you use gasketed joints for the spiral steel pipe, what is the effectiveness of the seal in meters depth of head with no leakage? Or are other measures of leakage if head is not used? What is the CSA or ASTM standards for that?
Doug, you want to take that?
Yes, okay. I guess the infiltration rate is the real question here. The gasket itself is very, very pliable and it fits over the corrugation and very tightly bound by the coupler itself. I cannot honestly give you an infiltration rate because I'm not real sure that I'm aware of that. So I can't do that. There is a specification off the top of my head. I don't know what it is for the dental tape that we use, but I could certainly probably dig that up and give it to you anyway. So I will pass that along to you. I mean, and you can pass it along, or the person can give me an email and I'll send it to them.
I can also add that we've done testing at Queen's University a number of years ago, and it was tested to a 10.8 PSI, which is basically the accepted standard for ASTM for watertight joints.
Okay, great. So yeah, what I'll do is I'll send you a list of the questions that were asked so that you have the contacts of the person that asked the question. I have other questions. What is used to connect the steel storm sewers to the concrete manholes?
Okay, yes. In most cases, the pipe itself is inserted into the manhole and it's simply grouted in there. So the hole is bigger and the space is grouted in.
Sometimes, Doug, we use a rubber boot also, you know.
Right, Ray's right. On the smaller diameters, there is a rubber boot that can be used. Typically around probably 450, 600, and when you get to 700, you're probably starting to grout everything in.
Mm-hmm.
And does this type of joints affect the service life at all?
No, no.
The next question is, what repair methods are available if the polymer coating is damaged, either during handling or installation?
I'll take this one, Doug. Sometimes, you know, polymer laminated steel, it's only a 10 mil coating on either side of the galvanized. So it can get damaged. You know, you pick it up with a forklift or you pick it up with a backhoe or whatever, and they nick it or whatever. It can happen. You and I couldn't do it. If I were to give you a hammer and have you hammer away, you're not going to damage that material. But, you know, we don't have the strength of a backhoe or what can happen there. So most of these cuts are from machinery or what have you. If that happens, they're always on the outside of the pipe. The inside of the pipe never can't get damaged. And that's where most of the issues take place in any pipe, is on the invert, you know, what's running through it, the water chemistries and so forth. However, if the pipe is damaged on the outside, we have two methods to repair it, provided it's not like crushed or what have you. If it's just a tear or a nick or what have you, you can use what is called a Denso 35 tape. This is the same tape they wrap in the oil industry, where they wrap smooth wall pipes into where they join two pipes together. They wrap it around the pipes. That can be used. Or you can use what is called Ranvar, and it looks like it's kind of almost a plastic type paint, where you can paint it within the cut itself and it will form over and seal it. So again, most of the nicks and bumps are always on the outside of the pipe, so they're not a huge concern, but you know, they should be repaired prior to backfilling if they're large. And we have documents how to do that. So if anybody, they're on our website, but if anybody ever needed something like that, please reach out to me. Because sometimes, you know, you get, I've seen damage where, you know, somebody must have fallen asleep and has gone down the whole section of the pipe and tore out a big piece. I don't know what they were doing. They must, like I say, they must have fallen asleep, or they must have had a vendetta or something. And even then, it was still repaired using the tape.
Really informative. Thank you, Ray.
Okay.
There's another question that came in. would we ever, or could we ever add 375 mm, 1100, 1500, and 2100 mm in the table HC1, HC3? In the QC are always wondering or asking why we don't have those information.
Absolutely. You can do it for pretty well any diameter. I think you know what that individual pointed out was probably because it's not on the standard list or what have you. You know, when you show the different diameters or what have you, but it's not difficult to you know, show the height of covers for any of those particular diameters. It's not an issue.
And just to add to that too, I mean, with spiral rib, we can make any diameter that you want. If somebody wants one that's in between one of those things, we can manufacture that. And typically, if they want to know what the height of cover is, that diameter by 6 number is applicable for CSP products. It may be, I'm not 100% certain what the other pipes, flexible pipes exactly, but that's how one can get to the height of cover for those sizes.
So if that person wants to reach out to myself or Doug or whatever, send me a note and I can give you a new chart based upon those particular diameters. It's not an issue.
All right, perfect. Yeah. So I'll, I guess if they didn't catch your email at the last slide, you can just reach out to anyone at Goodroads or ODRA, and we'll connect you to either Ray or Doug.
That would be great, Amin.
Thank you.
I see one more question coming. Oh, just a comment. Thanks. All right. So
You're welcome. You're very welcome.
I don't see any more questions coming in, and we're almost at noon here, so we'll probably end this webinar 2 minutes early. I'm sure everyone would appreciate that. With that, I would like to thank everyone for joining us today, and remind you that if you want to rewatch this webinar or share it with your colleagues, it's going to be available on our YouTube channel. And thank you again, Ray and Doug.
Thank you, Amin.
Really pleasure having you today.
Okay, pleasure. Thank you all.
Thank you, everyone.
Thank you very much. Bye.